guess where we got to, right? The last time. And we already did this already. We went through the entire code, right? Am I right? I can't remember, so I thought we got here and then I think we went through the entire code. Line by line. You guys can explain what happens line by line, right? I mean, the exam is going to be like that, line by line. Explain this code line by line. 2 points each line. So if you understand anything here, just ask now and then. If not, we go on. Shall I continue? You guys don't understand this code. But I think I explained it the last time. If I can remember. No. But we all know that for an Arduino sketch, right, we have two main functions. That's very important. What are they? The setup and then the what? Very, very important. Without these two functions, an Arduino sketch cannot run, right? So the first part of the code is for the setup. Have you seen it? The second part of the code is for what? Is the loop. So what does the first part of the code do? Then, then what? It runs once. So, I mean, for the 1 year, what does it do? Of course, it will run just once. But what does it do here? Yeah. You see, 2 marks, 2 marks, 4 points, just going like, just something like this. So also, so are we all clear there? Are we all clear? Right. So it means that this first line of code will establish some kind of a way to talk to the Arduino board from the PC, right? How to send data to it. And then I explained the last time that the line Arduino is all about libraries, right? And then if you see serial.begin, serial is a library, begin is a function within the serial library, right? And if you see begin is bracket 9600, what does that mean? The 9600. What? It means what? 9600. If you want the rate at which data can be transferred from the PC to the simple as that, right? So it means that we are transferring 9,600 bits per second. So within 1 second, we are able to transfer 9,600 bits, right? If you don't do this, there will be an issue between the PC and then the Arduino board, right? At what rate should the PC send data, and at what rate should the board receive the data? There will be an issue if you don't do this, right? Then we have pin mode 13 as output. Pin mode is a library, right? The library pin mode takes in two arguments, a number, and then whether that number is an input or output. The first number means that we are referring to a pin on the board, right? So 13, pin 13. Then we have to set that pin as input or output. But here we are setting it as output. Simple, right? Are we there? So now this code will run just once and set up everything for us. Then our next is the loop, right? And then I said that for the loop, it will go through the entire code and start again. Go through the start and start again forever until the board is powered off, right? And then I said that the first line does what? Easy. It does what? Uh, this line. It does what? This line on top of it. I mean, yeah, the first line. Mhm. It does what? one, -1 or something. I mean, if I read this, it means that I'm getting number and number. So I'll give you -1. So the first, what does digital write mean? Hey, so you guys don't know this simple code. I explained it line by line the last time. And the exam, as I said, if you do line by line, you are explaining the code line by line. So you need to know, and then you must use the exact, not the exact, but you must know the language of how to write it, and then make it make sense. And I'll give you a marks. If you make me to read any nonsense, I'll give you -1. So you have wasted my time. Of course, right? So we are there. What does digital write? What is it? What is it? Okay. Who knows what the first line? What does digital write mean? Anybody? Yeah. So the digital write is a library. I said. Now once you see anything like anything here, it means that it's a library, right? And then within that library, something must happen, right? You must give it some arguments, right? So the digital write is a library. That library also takes two arguments, right? The P number and whether that P should go high or low. So you are driving. I think I said that for the digital piece, they serve as outputs, right? You drive the outputs. The analog piece serve as well. Inputs, right? It gets something from the outside and then it feeds that to the MCU, right? So here for the digital write, we are writing to the digital pin, and then we set them as outputs, and then we give the pin number 80, as easy as that, right? Then once it means that here we are setting the digital date high. We are driving it high means that it's going to be on, right? And it's going to be on for how many seconds? Right? Okay, because I said this delay is also a library. It's a delay library, and then the delay library takes in one argument. Right? Anything you write, anything you put here means that it's in milliseconds. Right? So it will delay by 5 seconds. If you get able to take 5,000 from millisecond to second, you know that 5 seconds, right? Then after that, we do what? We write again, right? Call the pin 30 and set it low. You know that we are putting the pin off. Then we delay for another 5 seconds. Then after that, we do print. Serial.print just means that we are printing something from the console, right? So the first print is the counter value. So, but first of all, we set the counter here to 0. Then we print that counter. And then I said this counter comma 2 means what? I said it the last time. Or somebody within the class even said it. Huh? So what does this line use? Serial print. We know it will print something. It will print the counter value, but what does the 2 mean? So it prints the binary value of the counter. So if you don't bring the 2, what happens? If I do serial.print counter without the 2, what happens? Why are you laughing? Computer engineers, so if you don't bring anything, then you just print the counter. It prints decimal values. That is the default, right? But once you bring counter comma 2, then you print the binary value of the counter. Then after that, it does serial.print. What does this mean? What does this line mean? I explained this the last time. Okay, it just represents a space. Then we do serial document counter command. 60 means what? 60 bits. It brings hexadecimal value of a counter. Then serial document some another space, and then the last one it will just count. It will just increment the counter by one. Then loop again, right? So first of all, what will be the first counter value? So it will be 0 for binary, then space, right? Then 0 for hexadecimal, then space, then 0, right? Then it will increment to 1, 1, 1, 2, 2, 2, and stuff like that. Go on. Until when? Who knows? It will count until when? Hmm? So what do you think is the last value it will get to? Or can it just count forever up to infinity? Hmm? So we are counting 0, 1, 2, 3, 4. So when will it stop? Or when will you look back? Huh? 15. That's 15. So if you count 0, 1, 2, 3, 4, 5, up to 15, then it has what? Huh? And start again. It means that you guys over here program without even knowing what you must know when you declare a variable, right? You must know exactly what it means. So if I say, so you see that the counter is of type what? The counter, this one. What type is it? What data type is it? Huh? The counter. What is the data type of the counter? But you guys, haven't you learned any programming language? Something very funky about. Then, then, what is your point? Because you guys don't know hardware, you guys don't know software. So where you doing? What should you be doing outside? But you don't know hardware, you don't know software. So you teach you what? I mean, you guys don't fit anyway. Hardware, you don't know hardware. So if you don't know the hardware, I understand because I mean, in Ghana we don't deal with hardware like that. But at least you must know software. Right? You must be able to program something. If you don't know that one to them, what did you come in for? I mean, it's fine, right? But what is the data type of counter? Of the counter value? Eh? Guess what? Eh? 8. Int, yes. So the data type is integer, int. And you know what int means? It means what? So what does it mean? So as I said, so now once you declare a data type from the software point, right? Of course, you won't care like that. But you must know that anytime you declare a variable, right? It creates memory in the hardware. And I said it the last time. It creates memory in the hardware. It creates space in the hardware to store that variable. So int counter, it will create space within the hardware, within the memory of the hardware, and store the value counter there. Right? So what do you think is the space? How much space will you need to store? Int. Int depends on your operating system, right? If it's 32-bit operating system, then it means that we are storing 32-bit. We are storing 32-bit number. 32-bit number. That means that if you are storing a 32-bit number, our counter cannot go beyond what? Beyond what? 32. A 32-bit number does not mean that we are counting from 0 to 32. It means that we have created space, 32-bit space. 32-bit space means that we have each space, right, we are dealing with binary, and then we are dealing with the hardware here, right? We are dealing with the hardware. So each space stores 1 bit. So 32 bit means that I can store 0 to 31. So I have this 0 to 31 means what? The memory location. Not this 0 means that I'm storing something in memory location 0 here. This 31 means that I'm storing something in 31. Right? You understand? I create space in memory, but I number each of the the spaces from 0 to 31. That is what 32 bit means. 0 to 31. Now, within this space, I can store a binary number, either 0 or 1. Right? I said that for the last time, it means that the lowest number, a 32-bit space can store is 0, 0, 0, 0, 0, 0, because each space stores one binary number, a 0 or a 1. So the lowest number you can store is 0, 0, 0, 0, 0, right? Understood, right? The highest number you can store is, it means that each location is 1, 1, 1, 1, 1, 1, right? So if you take 1, 1, 1, 1, take the two of them, right? That should be the highest number, or that will be to count up to that number and then start again. Do you understand?
Yes, sir.
Shall I continue?
Yes.
Simple concepts. It doesn't go anywhere.
We understand.
So I continue. So it means that here, and again, we are using unsigned int, and I said that it means that the highest number will be what? Who can give me the formula? Unsigned int counter. So unsigned int means what? It means that I can only, the numbers are only what? 0 to what? Unsigned means that the only positive numbers from 0 up to infinity. But the int will now limit it to 32-bit kind of way. But it means that I need to know the highest number, right? And then that will be what? Who can give me the formula for finding the highest number? Huh? Uh-huh. To the power. And what is n? The data type, the int, right? So the int is what? 32. Uh-huh. Where is the minus one? Here or here?
No. The top.
Right? So for an unsigned int, we are using the entire weight to identify the number. So it's 2 to the power 32 minus 1. This is the highest number you can store. Or that is the bit before it overflows. Are you all there? Shall I continue? So this is what the code does. So it means that this code it will count up to 2 to the power 32 minus 1, then loop again, then start again. So the number will overflow. If I say overflow, you know what that means, right? I'm not going to treat that, master. I don't have time like that. Okay, so the next one is this code. And then I gave you guys an assignment to do. I hope you guys have done.
Wow.
So what does this code do? Let's hurry it down. This one quickly. Just go through it and just. And then, as I said, don't be afraid of it. It's just simple. And then I said, it's so close to human language that you can even guess what is the package reading, like English. It's close to human language. So it means that if we start to go into your area, right, computer engineering, like hardware coding, then it means that you guys will all run away. Because that one is not close to human language at all. It's close to the machine. Zeros and ones. You're coding. You have to write code that are closer to the hardware. to the AND gate, export gate, and something like that. That one, yeah, I do that. It's simple. Yes. And then you need a lot of time to study and then master it. But this one, yes, English language, very close to English language. And everything is in English language. Probably, let's take the first line. Let's take the first line, right? What do you think it does? Just based on your English, is it, I mean, uh-huh. You declare what? What about what variable? Hmm? Byte let bin. What is the variable here? So within constant byte, let bin is equal to 4. What is the variable we're declaring? Let bin, fine. Now, what is the byte here? Huh? Data type, right? So we that, and a byte is what? 8 bits. So I'm creating space in memory, 8 bit space in memory, right? And I'm storing let bin, right? And then what does this const mean? Constant. English language, yes, constant. Constant byte length is equal to 4. So it means that because I'm declaring a constant, I need to use the constant here. Right? So it means that the length is fixed to 4. That variable is stuck at 4. Understood? So you see how easy it is. The byte is the data type. The byte is means that you create space in memory, which is 8 bits. Like how we did it, but it's just 8 bits. So now from 0 to 7, create spaces 0 to 7. And then each location can store a binary number. So that's simple as that, right? Everyone there? The first line of code. We are all there. So I should continue. Then what is the next line of code? Uh-huh. What is the data type? Huh? Unsigned long. And then those two variables are on counter and off counter. Right? Now we come in the setup function, right? Always we have to actually declare serial of begin, and I've already explained that. And then we do the pin mode. We have to set the pins. Which pin am I writing to, or which pin am I trying to read from? Yeah, the pin is LED pin, and then the direction the direction is an output. Are we there? Now we come into the loop. Our main issue. Again, don't be afraid. Just English language. What do you think the first line does? Long RND one is supposed to random and then this but like for me, just let it go below. What do you think of that? The first line. And then that one. And then what do you do? So you see, what does random mean? It's a library, right? Anytime you see anything yellowish or something, that means it's a library. And then a library will always take an argument or more, one or more arguments. So here, the random is a library, it takes this argument, right? So the random library takes two forms of argument. So once I give it random and then I give it a number like, if I say random, and I give it 10, it means that it's going to generate random numbers, right? That cannot exceed 10. That cannot exceed the number 10. So it can generate like 1, 2, 3, 4, 5, 6, 7, 8, 9. But it shouldn't go beyond 10. That's all. That's simple as that. You understand? So now, if I put random, you know what this means? 0x means. Huh? 0x. It means what? 0x, then 7x. So just this 0x. Once I'm programming and I write 0x, it means what? It means Binary. 0x, 0x. Let's look at the definition. What does it mean? 0x. Hexadecimal. Right? You can write, and then if you can even look by, you can even look at the number. What does 7FFF means? 7FF is not a binary number. A binary number can only be 0 and 1. 1, 0, 0, 0, 0, 0, 1, something like that. Right? A decimal number cannot be, you cannot have F within a binary, a decimal number. It's 0, 1, 2, 3, 4, 5, but not F, right? Then we have hexadecimal numbers. Once I use 0x, it means that the number that we know is hexadecimal. Are we there? Okay, so now we go to the next line. Random. So the first line will generate a random number and store it in round 1. Have you seen it? Which has a data type of what? Long. Then the next line will also generate a random number. But here we are giving it 2 arguments. You see, minus 100 and then 200. Once I give it 2 arguments, it means that I'm defining the range. Now, I'm no longer giving it just 1 argument, which is the maximum number you can get to, right? If I give you 2 numbers, it means that the minimum number should be what? Minus 11, minus 100. The maximum number should be what? 200. So it will give you numbers between minus 11, minus 100, and then 200. Easy, right? Shall we continue? Yes. Now, we come and print serial.print, the random number that it generated. Then we print space. Serial.print, the second random number, then space. Now, let's get to the real part. Now, what does this line mean? This is it. Everybody knows that. Is that if what? Everybody knows that this helps. So we are here. If random number 1 is, so what does this one mean? Let me give you basic programming. This one I had now the kids in junior high school. Wow. So you guys should not be too out in computer with junior high school kids. So no. You should be worried. Because you're taking your jobs. Yes, I'm senior high school. Say in the system. No, my system. We are just unfortunate. Okay, let's go. What does it mean? And as I said, always look at it, right? I mean, this just if you know simple maths, you can actually figure out what is doing here. Okay. Pay attention, huh? No. I'm talking about just so what is it? I'm talking about inside. Within the range. Okay, so this means what? The random number. Yes. What does this mean? It is less than the hexadecimal number given for the range. What does this mean? Pay attention. We are trying to get there, so if the random number, the first random number generated is less than, that's right, it's less than, everybody knows less than, greater than, right? If that number is less than something, what is it? The hexadecimal number is here, then what is it? It's less than, there's this entire thing is a number. But what does this mean? Huh? It's what? It's less than half. And this one. How did you get by that? How did you get come by that? I mean, it's right, yeah, but how do you come by that? No, I mean, yeah, it's right. So if the random number is less than half of the decimal number given, right, then it will do this. But this is very, very technical, right? Once you, what does this sign mean? You guys know less than, greater than, and all the others, right? So if the head, if it's less than what, so this, so we have left shift, right shift, and then we have what? In programming, you must know all of these operators. Left shift, right shift, less than, greater than. Right? So why did we left shift the number? Why did we, this is very, very technical, and then this will, if you look within somebody's code, right? I mean, two people can write the same code. That will do the exact same thing. That will give you the same exact output. But one person's code, we will say, is efficient than another person's code, even though they do the same output. And then if I say this that if I say efficient code, right? By the way, I mean that that code is using less power to run, right? It uses less power, less memory, and then it will use less hardware, right? So as computer engineers, as I said, we're always thinking about the hardware. How much hardware is my code going to take? And then what type of hardware is my code going to use? That's what we must always be thinking about, not the software that where we don't care about code like that, right? So once you start to think what will the hardware use, then you begin to write efficient code. Now I want to divide a number, right? I want to divide a number by two. So somebody can just write it code that number to probably, let's say, 4. I'll take a number 4 divided by 2. Somebody will just use this operator. 4 divided by 2. And it will give me what? 2. The same, it will give me 2, right? That's right. But pay attention, pay attention. This is very important. So if you write inside your code, you use the divisor operator. Division of operation is very, very complex. Division operation uses a lot of hardware. Division operation uses a lot of power to run before it gives you an output. Right? So somebody can think, okay, if I'm dividing a number by 2, can I use an operator that will use less hardware, less power? And you will not begin to think, right? If I take 4, 4 in binary is what? If I take, let's say, I have a 4-bit number, so I've created space, only 4 bits, right? And 4 in binary is what? What? 1, 0, 0 is 4. But because I declared it as 4 bits, I have to put a 0 here. So this is 4. Every addition. So if I take this 4, and then I left shift the 4 by 1 bit, I right shift, sorry. I right shift this 4-bit number by 1. What happens? No. What will be the value? 0, 0, 1, 0. Right? So this is 4. If I left shift 4 by 1 bit, I get what? 2. I've effectively divided the number by 2 without using the division operator. Understood? Are we there? Now, you can try with 8. Let's say I take 8, the number 8. 8 will be, what will be 8? 8 is 1, 0, 0, 0. If I left shift 8 by 1, I'll get what? 0, 1, 0, 0. So from 8, I'll get 4. Effectively divided the number by what? 2. And then this operator in the hardware, It's very, very simple. It's just a left shift, just once. Now, if I'm supposed to do this same, if I'm supposed to do the same thing with a divisor, right? You have to go through an algorithm, right? You guys know that. You have to go through an entire algorithm before it gives you the output. But this one, you are just left shifting and it gives you an output. So anytime you're dividing a number by 2, right? And then that number can be raised to the power, can be 2 to the power something. Just shift, left shift. The same thing with multiplication. Another very complex operator in hardware, very, very difficult to do. It goes on and on. If I want to do that again, and then that number is 2 to the power something, what will I do? What will I do? If I want to do, so division was right shift by 1 or 2 or 3, and I will be able to divide by 2, 4, 8, going right. If I want to multiply a number by 2, what will I do? Left shifted by 1, and then like for here, if I have 0010 is 2, right? If I left shift this number, what do I get? This number is 2. If I left shift it to the left shift, I get 1000, and then that number is what? 4. 2 times 2 is 1, 4. You can try for that. So this is how you can tell if somebody is an efficient coder or he just. Are you there? Try continue. Is it difficult? Is it that it's just common sense? Common sense, just think like hardware engineers, not. Any question? Yeah. Okay, so here all we are doing is we compare if the number is less than 077 divided by 2, then it will digital write the LED high, and then it will print LED on, and then increment the on counter. Simple. Else, it will make the LED low, print LED off, then increment the off counter. Then it will come and print the on counter, the space, then print the off counter, the values, and then we delay by 100. It looks like it's simple. Right? So if I give you this code and then I say explain line by line, that's what you must write down. Shall I continue? Any question here? So you see, okay, now the next code. So what we have done, the first 2 codes or 3 codes we did, we were trying to read, or we were writing to digital pins. Understood? So we are talking about the digital pins on the Arduino board, how to write to a digital pin. That's what we did in the first 2 or 3 codes, right? So now we are seeing how will the EC and then the Arduino talk to each other. That's where we are going now, and then that's what these 2 codes do. So in case you are actually following now, you can write to a digital pin. If you want to keep any assignment, you can write to any digital pin you want, right? But we are now going to see how the EC and then the board talk to each other. And that's what these 2 codes will do. So what do you think the first code is doing? But I gave you the assignment. You guys are done with it, right? Without knowing these 2 codes, that assignment will be impossible to use unless you just hopefully use ChatGPT or Google Gemini or generative AI language model for it to generate code for you without you even understanding what it does. Who did their assignment? For 5 marks. Who did it? Everybody did it. Okay, so how how do you think your PC and then the board talk to each other? How does it do it? How? Can anybody explain to me the PC and the board? How do they talk to each other? Just a brief concept. You guys would have studied it somewhere, so I don't know. Anybody? I mean, you guys are even paying attention, and you guys don't even know it, and then you are still talking. The PC and the board, how do you think they talk to each other? As I said, when you are studying, right, don't try to don't try to just I mean for courses like this, because they're very important, just try to know the basics, like how the basics work, and then you'll be fine. Don't try to just like how I said what is int, and then you guys don't even know what int is. You just like your basics is shaky, right? But once you know this, you can now start to write very, very efficient code. Because you know that the int will store, because if for instance I'm storing a variable, and then I know that the variable I'm storing variable a. Pay attention. I'm storing variable a, right? I know that this variable I'm creating can never go beyond the number 3, right? This variable, I'm storing variable a. I know that this number can never go beyond 3. It's always 0, 1, 2, 0, 1, 2, 0, 1, 2, or something like that, right? And then I go and use int a, right? Now, what this code will do is that it will create 32-bit location in space. But because we are using only, it's going from 0, 1, 2, right? We are using only 2 bits of the 32-bit space. Only 2 bits of it. Means that all this space I've created is a waste. You have wasted hardware, right? Because this int is a 32-bit variable, and then it will create space, it will create space, but I'm only using 2 bits. It means that I'm not being efficient, I've wasted space. So it means that once I know this, I won't use int, but I must use, let's say, bytes, that will be 8 bits, and then it means that you are now efficient with it. You understand? So that's why once you understand the basics, you understand what each each letter means, each variable, each line of code means, and then you'll be able to write code that are very efficient. If not, you will just be doing whatever it is. You just be sounding codes and stuff like that. Are we there? So now, for we to talk to for the PC, for we to send data from the PC to the Arduino board, and then vice versa, we have to establish some kind of communication, right? And then we have a lot of protocols. If you go higher, right, if you go into your masters in computer engineering and stuff,
The buildings are shaking.
if you go higher, you will know that we have so many communication, kind of so many ways that we can use for two devices to communicate. What, right? One is what we are going to use here, the serial duplicate. The serial duplicate function is just a UART, UART, universal asynchronous receiver transmitter, right? Eh, but once they talk, they are getting marks, and then you are not getting any marks. But I know anybody who talks in the class. What? You didn't say it. Somebody said it. So for today, I know that somebody talked. The girl here talked, right? Your class right? Talked. I mean, give me correct answer. Then, I didn't see it. It is sensible. Right? And there's some guys here talking about that. Okay, then nobody told me about. Then my two guys at the back. And that, so, yeah, right, this guy took up the point. This guy just gave wrong answer from one. Okay, so let's see. So now pay attention. We have our computer here, my computer, right? And then we have our MC. You know what the MC is? Microcontroller unit, my board, my Arduino board, right? On the UART is a kind of two wire way of sending data to and from two devices. So it means that we are using only two wires, right? Only two wires. So there is one wire here known as TX. If I want to send data from the PC to the Arduino board, there's a port known as TX. That's where I'll transmit my data through, right? That data will go. That data will go here, and then there's a port on the MCU known as the RX that will receive the data. And if I want to send data from the board to the computer, there is a port here known as TX, the transmitter, that will send data to the RX of the computer. So the computer has two ports, TX and RX. The MCU has two ports, TX and RX. That's how they communicate. Only two wires. These two wires is actually just a wire, just wire. And then once it's just a wire, it means that I can transmit one bit at a time. One bit means what? Just 0 or a 1. I can't transmit 001 at a go. I can transmit one bit. Right? Now what happens is that if I send data through the TX, right, there is a buffer at the side of the MCU that will store the data frame before you begin to read. That buffer is about 64 bytes. Can take up to 64 bytes. That is how many bits? 64 bytes. That's how many bits? Eh? How do you get it? Right, it's simple. You know, you ask a lot of somebody is going to say, you have to. So it's 64 times 64 times what? 8 will give me the number of bits. So this can only store 64 bytes. So if the value I'm sending is more than 64 bytes, it will chop the rest off and only take from the LSB to whatever to the last 64 bytes, then chop off the rest. Right? Are we there? So the number or the value will get stored here. Now, if it gets stored here, what happens? Now, before you can read, right, the Arduino must first of all check if there's a number in the buffer. Right? So that's what we're using here. So what makes that's what I'm saying, the Arduino programming is just very easy. Now, to do this in hardware, you'll be writing a lot of codes to be able to just even check the buffer. A lot of, probably some 100 lines of code. But for the Arduino programming, we just use what is known as serial.available. How is it here? So serial is a library, is the UART library. We have a function known as available. That will check the buffer to see if there is anything within the buffer. If there's something, if you just count the values, 1, 2, okay, we have 10 values within the buffer, then you start to. So once we check, the serial available will give us a number. 1, 2, 3, 4. If there's something inside, so if there's only one bit inside here, it will return a 1. If there's 2 bits, there's a value here, there's a value here, it will return 2. If there's 3, it will return 3. That's how it does it. Now, if it doesn't return anything, if you check and there's no value, it returns a 0. So that's why we said if serial dot available is greater than 0, it means that if there's a value there, right, power pins, then we create a byte variable, and then we do serial dot read. Now, again, serial, the library, read is a function to read the value to the variable var. Simple as that. And then we do serial dot print, receive, just receive, and then we print the variable. Easy. So this is how to read, how the PC, and then how to send data from the PC to the Arduino board, and then display that value on the console. The what?
Does that mean the Arduino will receive the transmitter of the computer and the computer to receive the transmitter?
Yes. Are we there? Any question? Yeah.
What's the difference between the serial transmitter and the serial transmitter?
Which one?
The two prints data.
Ah, and I thought you guys were programmers, so I didn't actually different. Anybody should know this already. So once I do, pay attention, pay attention.
It's answering for bypass.
Yeah.
It's answering for
Pay attention, man.
The print depends the value on a same line. And the print line, if the value is more than the line, the print is not.
I mean, so that's why I was saying, somebody gets, I mean, you work with, how do I say it without also using? It's fine, it's fine. I mean, I was finding a way of putting it without insulting him. But right? I mean, you read the meaning. You read the meaning. That's how you were taught, right? You read the meaning, but nobody explained it like you. That's why, right? So the serial print will print on one line, and then it will move the cursor to the next line. So if I'm printing again, so if I do serial dot print receipt, it will print it on one line. Now if I come to the next line, right, serial dot print again, it will print that value on that same line. Serial dot print that same line. But if I do serial dot print line, it will print the value and move the cursor to the next line. And wait, so it means that if I do serial dot print, so like here, if I do serial dot print receipt, it will print receipt on one line. And then if I do serial dot print line, it will print that value on that same line, receipt, like this, receipt, some value. And now move the cursor to the next line, to my next line here. And then anytime I'm printing again, it will print that value on this line, move the cursor, print on this line. You see how it does? Are you there? Okay, so now here, what happens is that if I do this, right, and I run the code, I don't have time to run the code, but you guys can go and use simulation to run the code and see how it goes. If I do this and then I enter a value, right, let's say I enter the value 1 on my PC 1, and then I click enter, right, what do you think it will print on the console? What do you think it will print? Now let me just run one code and see. If not, and I'll talk a lot, and then the next time everybody will say I didn't say anything. So I was saying that if I enter the value 1, right? Uh, sketches. Mm, But you guys did the assignment. I mean, for those who have not seen the board before, there is it. And I believe you have not seen it before, right? I have seen it. So this is the code, right? So what I'm saying is that so if I run this code, what do you think will happen? Okay, so we know the steps to run the Arduino code, right? Connect your board. Once you see this line, this green light here, it means that there's power to the board from the USB, right? If there is no green line, it means that you are in trouble. Either your board is damaged and then you have lost 1,000 CDs or something. Now, if you are done, you come here, select the board because I've already installed the board to I showed you how to do all of this. So you guys have no issue. Then I verify. I think we did this the last time, and I showed you how to run, and then it will generate some values at the end, and then stuff like that. I showed you everything, and then there's some that's just what I'll be asking you guys. It's as simple as that. Right? So it will compile the code, give me how much RAM it will use, give me how much flash it will use, and once I check those values and see that it's about what the board has, then I'm in trouble. I'm going to really write my code to use smaller RAMs and stuff like that. I've already done that. Huh? So it's done compiling, and then I'll just upload. I already have. So if you had a code running already, so once you program the Arduino board, right, that program stays in the flash, and then you know flash is not easily erased until you re-program, right? So if you write your Arduino code and then you even off the board and on it again, that last code will start to run without you doing anything to it, unless you press the reset button and then it stops running, right? So I had some code running already, so that's why it's doing this. Okay, so now I'm done, right? So this is the console. So I'm going to press a number here, and then it will go to the Arduino board. And because I'm using serial.print, it will now print the number that is stored on the board on the console, right? So if I enter one here, what value do you think it will print? Huh? What value do you think it will print on the console? 9. So you see, it prints received. What is the number? 49. Then it prints received 10. It prints received 10. Do you know what that means? I just entered one and then it printed the number 49. What does the number 49 mean? I mean, if somebody answers this one, they like for 10 marks. I mean, the person shouldn't come for lectures anymore. And we just do the first automatic 80%. So the first thing is 1. He gave me 49. If I bring 2, what do you think he gave me? If I bring 8, what do you think he give me? 8. 8. Higher, higher. So now pay attention. If I read, if I read a value, if I use serial read, right, and then I enter 1, right, it's printing the ASCII value of 1. You know what ASCII values are? ASCII. ASCII. So just search for the ASCII value of 1, and then you know that common sense 49. Yeah, ASCII. Yeah. So you guys know what ASCII values are, right? So the ASCII value of 1 is 49. It's as simple as that. So it's printing ASCII values. Now, what does the 13 mean and what does the 10 mean? When you write printing in C, anywhere, right? There are some functions that we don't actually define and stuff like that, but they are very important. So we have what you know as how will your line end, right? When you write code, your line always ends with something like backslash r and then backslash n, right? You know what this means in C plus or whatever coding you do. The line always ends with backslash r and backslash n. That is, this means new line. This means return carriage. So it gives me the number, and then once you see backslash r backslash n after the number, it means that that particular code has ended. That particular line within the code has ended. I mean, this is just C programming and stuff like that. So now the most important thing is that if I want to print my values in integer, all I do is use the other code. Where is the other code? So this one will print the ASCII values of the number and the next code, this one will print the integer values. Why? Because I'm using, instead of using serial.read, I'm using serial.parseInt. Right? So it will print the actual integer values for me. Simple. So now I know how to print ASCII values. I know how to print what the actual integer values. So that's what the assignment was for. I don't know. I think it was to get a value, an integer value from the PC, and then turn on the LED for some seconds and stuff like that. Very, very easy. Right? Are we there? Now another technical one. So here, anybody who answers it again, more marks. So if I do serial.parseInt, I want to just show you some technicality here. Let me see how you guys are thinking. But I know that, oh, no, okay. Let me not even doubt you guys. I know. So, are we done? Okay. So I upload the code So now pay attention here. I'm going to enter a number and see what it gives me, right? Then I'll ask why he gave me that number. So if you release me and then you might get it right. If not, these are simple tricks you can use to like the student thinks they understand, but just a very simple trick will get them confused forever. Right? So where are we? We come to the serial monitor. Let me clear the serial monitor. And then if so you see that now if I enter one, it prints one, then a zero. Then that zero doesn't matter. But it prints one. If I enter two, it prints what? Two. If I enter 255, what will it print? What will it print? Anybody? 255, right? If I enter 256, what will it print? Huh? Come on, say, just think small. Just pay attention. If I enter 256, I enter 255, it gave me 255, right? If I enter 256, what do you think it will print? 257. Let's enter it. So I enter.
Yes.
What did it print? Zero. Why? Come on, come on, come on. Common sense. It- but why? So if but where do I get it from? So okay, so look, just look at the code, right? Why is it that when I enter 255, you give me zero? Why is it that the largest number it can print or it can print out is 255? Why? Again, because you say, why don't you get the largest number you can print is 255? Pay attention, it's in the code. Everything is in the code. What is the data type? What is the data type? Byte. Your byte is what? Eight. Your byte is what? 8 bits. So common sense. A byte is 8 bits. The largest number a byte can store is 11118, eight of them. Right? And 1118 of them is 255. Now, if I do, please pay attention. If I do 256, the binary number of 256 is 1, then 8 zeros, 0, 0, 0, 0, 8 of them. So now because this, what I do 256 is 1, 0, 0, 0, 0, 0, 8 zeros, right? Then the data type is can only store 8 bits. So it picks from the LSB to the last bit, which is 0000, and then it drops the 1 because it has no space to store it. So that's why I say once you create a data type, byte, it creates space in memory and store the number there. 256 is beyond that 8 bit. So it will chop the last one off and print 0000. So that's why I entered 25. If I enter 256, it printed 0. See? So everything is always in the code, byte, 8 bits, and then 256 is 10008. So 9 bits. But we are storing a 9-bit number in 8-bit space. Impossible. It will just store the 8 bits, and then the MSB, it throws it away. That's why it prints that. So now I could have just solved this by just saying int var, and int is 32 bits, and then if you can store just 9, you can store it, and then you can print it. As easy as that, right? What? Any question? Any question? Any question? Hey, they can shoot. Okay, are we there? Shall I continue? Any question? So now the only thing to pay attention is that we have data types. Now each each Arduino board has its data type and then the amount of space that that data type stores. Very, very important, right? So if you take the Arduino Uno, right? The one you guys would have seen, the bigger one. 1 byte is just 8 bits. You can use 1 byte for a Boolean number, a character, and then bytes. You all know this, right? 2 bytes can store, and then for 2 bytes, we have int for unsigned int. You guys have already explained this. And we have 4 bytes, right? Then we have for 4 bytes, we have long, unsigned long, float, number. You guys know what all this means, right? But the thing is that if you take an you see, an integer for the Arduino Uno is 2 bytes. Have you seen it? Pay attention. Have you seen it? On the Arduino Uno, an integer is 2 bytes. But on the Arduino Nano, right, an integer is 4 bytes. So there are differences. Have you seen it? On one hardware is 2 bytes. On another one is 4 bytes. So on one it is what? 16 bits. On another is what? 32 bits. So you have to pay attention. So anytime you're using the Arduino board and then you declare an int, the highest you can store, it means that the space to create will be 16 bits. You can't go beyond that. But when you're using the Arduino Nano and then you declare an int, it's always 32 bits. Right? Are you there? Okay. So now, yes, we pay attention. Our first site, we dealt with writing to the digital pins. Our next one was how to read, how the PC and then the Arduino board communicated, right? Now the next is the analog pin. How do we read from the analog pin? That's what we're doing, right? And then I said something important, and I know probably everybody has already forgotten. I said that if I in my code, if I declare a number, it gets a number like 30. What does it mean? Am I referring to the digital pin or the analog pin? So if I do D13, what am I referring to? D13. If I do F13, what am I referring to? F13. What pin am I referring to? Digital or analog? F13. Digital or analog? That's an error. It's an error. So you see how easily you guys can be tricked. So for the pins, you can actually use A3 to declare an analog pin. But if I just say 3, you say what? As easy as that. And then it will what does it F something? Then you guys are just confused. An error. It will be an error in your code. Right, so now we are going to see how to read from the analog pins. Very, very important. Right, and then this is the code to read from an analog pin. Who can tell me what the code is doing? Let me give you just 5 seconds to think about it. Because I know that even if I give you 3 hours, you won't know it. So you see that the code seems the codes always seem very simple, but when you start listening, there are a lot of technical details within each code I give you, right? A very simple thing, but it means a lot, right?
Yes.
Right. So, what do you think the code does, or how do you think it is reading the analog value from the pin? Yes, sir. How is it reading? How is it reading? Okay, so let's start with the first one. So we are just declaring a constant data type byte analog pin, just a variable called analog pin, and then we are giving it A2. I said that once you do something, A something, right? It means that it's an analog pin. So whether you are reading or writing for it, that will not depend on us. Now, if I get into this code, right? The first line is so now for the digital pins, I use digital. You see that I always use digital right, like digital right. Common sense will tell you that digital right is I'm writing to digital pin. So another again, common sense again. I want to read from an analog pin. What? What's that? Why are you laughing? Common sense. Don't think a lot. Okay, if I say common sense, I guess don't think too. Don't common sense. Don't think some kind of complex thinking and start to run your brain and just within. Okay, so now common sense. As I said, I want to read my ex. I'm reading from an analog pin. What library will it be? Analog read. As easy as that. Analog read. So that's why I'm using the library here. Analog read. And then analog read, then the pin number. So because I declare it as A2 here, analog pin is A2. I'll just put analog pin here. And then it will read the value on that pin and then give it to the integer variable here. Right?
Yes.
Now next, so this is where the technicalities come in. So I've gotten the analog value, right? Now I want that the analog value in volts. So I'm reading the pins, you know that the pins are all about the voltage, either in 0 volts or 3.3 volts. So I do the value I read times 303, or I can say 3.3, and then divided by 1023. Now the thing is, what does this? I know you guys know what this means. Forget about it. It's 3.3. So I take the value times 3.3. It just means I'm converting that value to a voltage value, which will be 3.3. And then I divide that by 1024. What do you 1023? What do you think 1023 means? Another very technical. It's not even very technical. Once you go what you're doing, it's just common sense. So 1023. Who knows what it means? 1023. What does this value mean? 1023. 1023. We have only going to be listening. Please, keep quiet. I mean, for people who don't know today, they're just people. Okay, empty barrels. Sorry. I mean, okay, so please, that's just by the way. I mean, you guys. So this is very, very technical here. What does 1023 mean? The value here. What does it mean? The reference to that. So the five volts don't really there. So here just this is actually 3.3, not 303, 3.3. So it's like this. Okay. It's like this. I take the value, right? The value I read, I divide it by 1023, and then I convert it to voltage by 3 times 3.3. So okay, just forget about that line. This is how it's like. I take the value, divide it by 1023, and then I convert it to voltage, 3.3. So I'm saying that, what do you think this 1023 means? The highest. Okay. I mean, you are very close here. But if you said in an element, anybody didn't get it right, I would have given it the entire mark. I'm very close here. Yeah. Yes, right. If you were paying attention from last week, I said that we spoke about an ADC, analog to digital converter. Right? I said, you see, if you take a microcontroller, pay attention. A microcontroller is a digital kind of system. It's digital system. It's a digital system. It only understands digital numbers. Right? That's what it understands. Digital numbers. Now it cannot understand analog values. Right? So if I read an analog value and give it directly to the macro, once I read an analog value and give it directly to it, it won't understand what that value is. You know, analog signals are like this, right? Do you know this? So this something like this is like it's like an analog signal, it's a form of an analog signal, right? Right? This is an analog signal, right? And then once we're talking about voltage, right? It means that I can read from 0 to 3.3. For, pay attention, for the Arduino board, 0 to 3.3. But how many values are between 0 and 3.3? If somebody says 3, how many values do you think are between 0 and 3.3? Infinity. There can be 3.31, 3.2. There are so many values, right? But I want to limit those values, right? So once I take my signal and then I pass it, what the ADC does is that it takes the analog signal and then it converts it to what? Digital. But how does it do that? What range? How many values can it actually take? Right? So I limit it to 1024 values. So instead of taking all the values here, I limit the value to probably 0, 0.1, 0. And then those points, the points here are up to 1024 points. So I can pick from here, here, and stuff like that. So the 1024 is the number of points I can pick from in the analog signal, and then use that one to now convert to the digital. Understood, right? Are you there? So at each point, it picks another signal. So this can be 3 point something or 2 point something. But those points are. Why are you laughing? I mean, it's just simple. You guys have understanding signals and systems, right? Right? We have. So I have to sample, first of all, I have to sample some number of values. That is not what I'm talking about. Like from here to here, I sample some number of values. But how many points can I sample from this signal? The highest is 1023 points. So I can sample from here, sample from here. But we are talking, the range is from 0 to 1023. points that I can sample from. That's simple like that. Right? Now, after I've sampled, it means that if it picks the value, right? If it picks the value will be an analog value. Probably it will pick it will be something like 3.1. Then this 3.1 will be converted to a digital value, which might be probably 1021. Then we take this value, we divide it by the 1024, and then we do it times the 3.3, and then we get the voltage equivalent of it. Easy. Easy. Are we there? Not what? Not 2, 3. Ah, sorry, 1023. Right? So we all understand the float. Volt is float. We understand that line. Then the next line is S print this. What does that line mean? I mean, you guys just go through the slides before coming to class. You just get up and just tell yourself. You get up and farm and just probably focus on some of you going back before coming to. You just get up and tell yourself into class, right? I mean, if you took the course, right, just before you came to class, well, just 1 hour to get to class. If you took this code, kept things down, generated AI, large language model, ChatGPT, and say explain line by line, without giving you all the answers. For you to just understand, and then you just want to learn. You already know what it's doing, but probably you don't understand something, then this is me, and you just move forward. That's how you move forward. But you don't just carry yourself and then happen. Now, learning is even easier now. Just copy this code, just put it in ChatGPT, just go there. Just say, explain line by line, what each line of code does. If you don't understand, you can need to form it more. More, then use more. Okay, so S-Print. What does S-Print do? So, but what are we doing in the S-Print? We are doing S-Print, MSG, we are doing ADC, digital body. What does this mean? It's presented C plus C. Come on, so this is the use what? Huh? It's printing, it's converting the number to decimal. Presented D. It reformats the number to decimal for me, right? Then I do vote, and then I come 0.2f. What does that mean? Floating point, right? But 0.2 means what? Hmm? Yeah, so you know that for floating we have 0.0001 or something like that, but it limits the decimal point to what? 2. This is just C programming, basic C. And this bar here will be printed here, this bar here, this goes here will be here. You know what that is, right? So what does the S-print do? So now probably, if we were paying attention, right? The print, and then the print line. Print, very, very important. Print. If I use serial dot print, right? What it means is that I can only if I use them. Hey, what's that? If I use serial dot print and then something inside here, the most important is that I can only print one data type when I use serial dot print. What else means is that I can only print a character. within it. I can also print a number within it. But I cannot print both. You know, a character like A, B, C, D, and then a number 1, 2, 3 are different data types, right? I cannot mix different data types in one print, in one set of print. I hope you guys know that, right? So now, if I'm supposed to do this, if I'm supposed to do ADC, I want to print ADC, and then the voltage, the valve, and then the voltage in. How will I do this using the print? Serial of print. How will I do that? So now, instead of using the S print, I want to use print. So what will happen is that I will do, I said I cannot print different data types. Now, if I say, in better comments, ADC are characters. ADC is character, then column. ABC column are characters. So what I can do is that I can print serial dot print to bracket ADC column in one line. Pay attention. Serial dot print ADC column because those are characters. Now you know that the voltage value, the volt, the energy value there. I'm printing var. Var is integer, right? So once I print this in one line, I'll come and print again. Print, then into bracket var. Every attention. Because that var is a different type, right? Then I come and now print volt. The volt column is characters. So I now do print volt. Right? Then print again the floating point number, which is a volt. So instead of using one line of code, right, I should use about 4 lines to just print that line. 4 lines of print to do that, right? But there's an easier way. If I format everything, are you paying attention? So the easier way is to use the S print. But what the S print does is that you must first of all create a character array. That's what I did in the first line of code here. So car MSG messages 30. What that means is that I've created an array of 30 characters. So now the important thing is that you must know how many characters you are printing. I got attention. How many characters are printing? If it's 10, then I can put 10 there. If it's 20, I can put 20 there. But here I just use 30. So I'll be able to print 30 characters or cram 30 characters within it. So I do that, and then once I use the S print, I can now use this entire thing. S print, message, ADC, this. And then what happens is that all of these values or all of this will be stored in the message, and then I can now come and use the S print and print MSG, and then you just print the ADC column, then the column solution. That's something like that. So instead of using the 4 lines of code, I can just use this line here, and then to print everything. But I cannot use serial dot print and do this. It will give me an error. Right? Any question? Yeah. The S printed, yeah, that's the syntax. Any question? You guys there, you guys are the electrical engineers, right? You chose the wrong course. I think you guys chose, who even told you to come and do embedded systems? I mean, by spine, I mean, if you are using Arduino board for your project, right, then probably to help you. Any question? So you all understand everything. In case I give you a simple test right now, you guys will So the last one, the last one. Let's finish last one. We have 7 minutes now. So last one. What do you think this is doing? So like I said, if code is supposed to show you or teach you something new, that's the purpose of it. I kept it code for a specific reason to show you something, something new or there's something you might have known. But all of this, you guys should have known all this. Nobody will, nobody will sit you down and try to teach you. I don't know nobody from the start. I mean, nobody that well. You know that, right? How did they teach you guys C++ or C? Now, I mean, how do so, what are you doing here? So let's go into the quickly. So what we are doing is that micros start time again. English, please pay attention. Start time is equal to micros. What do you think this is doing? What do you think that library does? What do you think the micros library do? So how does it calculate the time? How does it calculate the time? Hmm? So what the micros library will do is that, right? If I start my Arduino board, right, it starts to, it has a counter that starts to count, and then that will, and you can say that's the time. So it starts to count, and then once I declare micros, once I call the micros library to take the time in this at and store it in start time. Have you seen it? So if it has started, if the board is running for let's say 5 seconds, right? It will take that particular time, the 5 seconds point, and store it in start time. Have you seen it? So the current time we are in, that's what it stores in the start time, something like that. Meaning, that's why I said start time. Right? It is giving you a hint. Then I do this. So for here, what I'm trying to do is that I'm trying to see the amount of time it takes to read the analog pin. So this entire code, if I say summarize this entire code in probably 2 or 3 sentences, right? All we are doing in this code is that I'm trying to see the amount of time it takes to read the analog pin. So when I read the analog pin, how much time elapses? That's something like that. So here I do, and then I read the analog pin a number of times. That's why I have the buffer length here. Obviously, the buffer length here. So 8192 times. So from 0 to 8192. So I start from 8. I start from 0. Then I read the analog pin, right? Then I read and read and read and read several times. And after that, I come and calculate the duration, the time it took to read 8192 times of the analog pin, right? So and then all I do is I take the micros because when I started to read it, I stored the time here, that time. Then I come and take micros minus the start time. So the micros will give me that current time after reading micros for the start time, and then to give me the duration. And I just read the duration. What? What's the meaning? Buffer length. Any question? So like I'm giving you codes like this. The first question will be summarize this code in 2 or 3 lines. So what does the code do? As in then the next bit is create this line of code. Are you all there? Very person. So I'll be taking the assignment again to next week.
Yes, sir.
So the format will be out and I'll test it on your PC. So when I don't know PC, I'll just connect the board and test it if it works as now. Like how I told you. Yes. But I hope you guys understand the assignment. You guys understand the assignment, right? Pay attention. So that the assignment is just to you get an input. Pay attention. The assignment you get an input. So you will give it an okay. Once you design, I'll enter an input, and I show you how to design code that will where you can send a number from the PC to the board. Right? Pay attention. So you get an input number between 1 and 9. So I'll enter 1, 2, 3, or up to 9. Right? And then this number should be sent to the Arduino, and then it will turn the input LED. You know there's an input LED here, which is dictating. So turn the input LED on for the number of seconds I entered. If I entered 5 seconds, so if you take the input LED on for 5 seconds, and turn it off.